We're looking at two different boxes. The one on the left has blue molecules, and the one on the right has red molecules. Now you should be asking yourself, what's the difference between these two boxes? Hopefully you came to the conclusion that one is denser than the other. So let's label it. The red is high density. That's because the molecules are close together. And this one on the left with the blue molecules is lower density because there's more space between the molecules. Now, which one would be easier to travel through? Hopefully, you're thinking this box on the left, because the molecules are so spaced out, there's a lot of room to travel between the molecules. In this high density scenario, the molecules are so close together that the gaps are smaller, making it more difficult to travel through. This is how waves operate. If a wave has a huge wavelength, chances are it's going to be blocked by this high density material. But it may be able to get through low density material. So, what does that kind of mean? Let's say we're talking about radio waves. Maybe you need to pause, maybe you want to check out your reference tables. Radio waves have a large wavelength, right? They have a large wavelength. So chances are they can make it through material like this, low density material. They can pass through it, even though they're really, really large wavelength. They can fit between these gaps. But chances are they can't fit between these gaps. So what does that mean? Well, let's think of an example of a radio wave, like our Wi-Fi. Our Wi-Fi's work on radio waves. That means if you have a door, chances are, if you're in the other room, you're separated by a thin wall, you're separated by a thin door, you probably get pretty good Wi-Fi reception. However, if you happen to be in the basement, or two floors away, that wave has to travel through the flooring. That flooring is more dense, which means not as many Wi-Fi waves will make it through that flooring. Probably means your Wi-Fi probably sucks on that floor.